What is going on, everyone, and welcome to the Fusion 360 tutorial series. This is day 4 of learning Fusion 360 in 7 days. This tutorial series is for complete beginners with Fusion 360 in order to learn the ropes from sketching our first component to assembling geometries by day 7. Today, we will be taking a look at how we can use the thread command in order to model standard sizes of bolts and nuts, as well as seeing how construction planes may be helpful in order to mirror certain desired features we create along the way. Let's get into it. In order to start sketching our nut, we need to first sketch the nut's hexagonal shape. Luckily for us, there is a polygon sketching aid built into Fusion. But first, let's enter sketching mode. Now we can go to the Create drop-down section and find the Polygon section. A circumscribed polygon is where a circle can be drawn inside a polygon so that all of its faces or edges are tangent with the circle. And an inscribed polygon is where we can draw a circle that passes through all of the vertices of a polygon. Or edge polygon, which simply means dimensioning one edge of the polygon, and the program will sketch the rest around it. For this example, I'm going to go ahead and choose the circumscribed polygon, and as we can see, this window will appear here. And like the circle command, we will put the origin of the polygon at the global center of our environment and drag outwards. As we can see, two dimensioning boxes appear. One for the number of edges we want our polygon to have, and the other for the radius of the circumscribed circle in the polygon. Since we are modeling a nut, I will choose the number of faces as 6 to have a hexagon, and for the radius of the circumscribed circle, I will put 5.5 millimeters. Click again, and there you have it. That's how easy it is to sketch a polygon. Next, we'll draw a circle inside the hexagon, which when we will extrude will represent the hole that is present. So grab the circle command and snap it to the middle of the environment and drag outwards. And I will dimension the circle to have a diameter of 8 millimeters. Click on OK, and there is our circle. Now we can use the extrude command to only extrude the area between the circle and the hexagon. So exit sketch mode and grab the extrude command and select the outer area. And let's extrude this by 5 millimeters. Press on OK. And there you have it. We have the basic shape of our nut. As you may have noticed, I took a bit of a shortcut, having sketched the area where our hole was going to be before I extruded the shape. You could have also just extruded the regular hexagonal shape and then gone back and in a separate sketch draw the circle and cut it from the center to the bottom. Either way, this would have worked. Now let's add the threads to our hole. To do this, we can find the thread command, which is in the Create drop-down menu, and that will open up this window here. First, we need to specify which face we want our threads to be on. In this case, it will be the inner face of our hole. The modeled checkbox just underneath gives us the option whether we want the thread to be physically modeled or just give a visual representation of what the threads are going to look like. This checkbox below, the one named full length, gives us the option on whether we want to extend the threads across the entire length of the selected face, or if we unselected box, we can choose to specify the length over which we want the hole to be threaded. For thread type, this allows us to choose the thread standard we want. We will leave it as isometric profile for this example. Size allows us to specify the diameter of the thread. Please note that the diameter of the thread does not need to match the diameter of the hole that we've created. The hole that we created was just simply a placeholder to specify that we want threads in this area. So if we wanted, we could choose a thread diameter of size 1 millimeter, for example, and this would actually fill in the hole that we initially created. But for now, let's leave it to a diameter of 8 millimeters. The designation specifies the exact standard thread we want, specifying the diameter and pitch of our thread. Class refers to the tolerance class, which determines how tight or loose the fit of the threads will be. Here we only have a 6H since we chose the thread type as metric. Direction specifies if we want the threads to be right-handed or left-handed. And finally, the remember size checkbox allows for the settings that we chose here to be saved, which would allow for easier threading if we had many holes that we wanted the same specification. Now that we've gone through all the options and that we have chosen the threads that we want for our hole, we can go ahead and press on OK. And there you have it. Now we have the hole that was going through our solid is now completely threaded. Very cool. With the threads added to the hole, we can go ahead and add those chamfers around the edges to make the nut and clean it up and make it look a little more realistic. To do this, let's enter sketch mode again, and on the top face, press on the sketching icon, and then press on the top surface. Next, we will sketch a circumscribed circle in the middle of our polygon. So let's grab the circle command and connect its center to the global center of the environment. And then drag out to the closest edge until we see the little blue triangle and blue circle appears. The blue triangle means that we are at the midpoint between two vertices on the edge, whereas the blue circle means that the edge we are connecting it to is tangential to the circle. By clicking again to confirm the circle, we can see that the circle turns black, which means that the sketch is fully defined, so that is good. Now we will exit sketching mode by pressing on the green check mark and grab the extrude command from the create section of the toolbar. For this extrude, we will choose the circle that we have just created. Let's drag the extrude arrow slightly downwards to start the command, but then let's change the extend type to through all to go through the solid that we currently have. The taper angle in this case, we are going to put 45 degrees, or you can also just change this to any angle that you want your chamfers to be. And finally, for the operation, let's press on the drop-down menu and choose the intersect command. This command will allow us to keep the interaction between the current solid and the solid body we are extruding from this command, and will allow us to also get rid of the corners of the hexagon, since this will be not within our intersecting zone. Press on OK, and there you have it. We have now added chamfers to the vertices of our nut. Now we could repeat all of these steps in order to do the exact same thing on the bottom face, but this would be the perfect time to introduce the mirror command in order to save a little bit of time. The mirror command is extremely useful since it allows for bodies, sketches, or even features to be mirrored or duplicated across a plane or axis. This is especially useful if the feature took many steps or used difficult geometry, allowing the user to recreate it with ease. So to start, let's go ahead and go to the Create section of the toolbar, press on the drop-down menu, and grab the mirror command. This window will appear here. In object types, this specifies the kind of thing we want to mirror, which can either be the body, face, or feature or component. Since the thing we want to mirror in this case was an action of extruding, we will choose the object type as feature. For the object, we need to select what we want to mirror. In this case, I will go down into the timeline and choose the latest extrude that we did by pressing on the last extrude symbol. Mirror plane is the plane over which we want to mirror this feature. Now, since I created the feature on the top face, I want to duplicate this on the bottom face. So we would need some sort of plane at the midpoint between these two surfaces, which we don't currently have. So let's close the mirror function for now to add a construction plane that will act as our mirroring plane. To do this, go to the construction section of the toolbar and press on the drop-down menu. Here we have a whole bunch of reference planes and axes that we can create in order to aid construction of our model. I would encourage you to explore the different options that we have here, but for now, let's go ahead and grab the midplane command. We will then select the top and bottom face of our nut, and then the program will add a plane at the midpoint between the two selected surfaces. Press on OK, and now we can go back to the mirror command to duplicate the feature we used to create these chamfers. Press on the Create drop-down menu and go to Mirror. For the object type, this will be a feature as we previously discussed, and we are going to choose the object as the extrude from the timeline at the bottom. And then for plane, we will choose the midplane that we just created. And as we can see now, the program is previewing the mirror it will perform. Press on OK to confirm the command. And there you have it. The chamfers we created on the top surface have now been duplicated to the bottom surface. Very cool. Now with the nut created, let's go ahead and switch gears a little bit to the bolt to see how the thread command works for creating bolts. And it's very, very similar to the nut, but instead of having a hole, we're going to have a face of a cylindrical body where we want to apply our threads. So let's grab the thread command. The face we will choose is this cylindrical face. And for fun, let's deselect the full length box. That will make a couple more fields appear. Offset, this refers to how far from the end we want our threads to start. So if I put 5 millimeters, we can see that there is a flat section and then our threads and then another flat section since our threads don't extend to the end. Length refers to how far we want our threads to extend from the starting surface. In this case, I will put 15 millimeters to show that we can easily make partially threaded bolts. And to demonstrate what the modeled threads look like instead of the imaged threads we saw earlier, let's check off this box that says modeled threads and then press on OK. And by comparing this to the nut that we had before, we can see that the command physically cut out the threads out of our object rather than just creating an image on the surface of what the threads are going to look like as we saw with the nut. And that's how easy it is to create partially threaded bolts and nuts using the thread command in Fusion 360. So that is going to be a wrap for day 4. A slightly shorter video, but today we explored the power of the thread command in order to make some hardware. In the process of doing this, we also learned different tools such as the Polygon sketch command, midplane construction planes, and the mirror command, diversifying our arsenal to understand what is achievable in Fusion 360. Unfortunately, this will be the last day of single body modeling, but look out for day 5 where we'll dive deeper into the world of multi-body assemblies and connections, elevating our CAD skills even farther. If you found this video helpful, don't forget to leave it a like and subscribe for more engineering content.